Hi, good morning, my dears. Welcome to today's session about Miller indices. What is that? Miller indices. Let's see what is the definition of Miller indices. Miller indices are used to specify directions and planes. They are used to specify direction and planes of home lattices and crystals. In lattices or in crystals, the number of indices match with the dimensions of the lattice or the crystal. For example, we are taking one dimensional crystal. So in one dimensional crystal, how many index are there? In one dimensional crystal, there is only one index. If you take two dimensional crystal, it will have two indices. If we take three dimensional crystal, then the indices are 3. So like that, the indices are depends on dimension of the crystalline body. So the concept of Miller indices is introduced by Miller scientist. So it is called as Miller indices. Symbolic representation. What is symbolic representation? So here the negative number or directions are denoted by bar symbol. So on top of the element, actually the Miller indices are represented by small alphabet of HKL, small alphabet of HKL without any commas. Here the negative number or direction is indicated by bar symbol. Here the Miller indices are represented by certain patterns. The first pattern is indicating direction. Second set of pattern is indicating family direction. Third set pattern is indicating plane direction. Fourth set is family of planes. Direction, family direction, plane, family planes. So like that, we are expressing the different types of the planars with different bar bracket symbols. Miller indices for the directions. Let we need to consider a vector r passing from the origin to a lattice point. Passing from origin to a lattice point. It can be written as r equal to r1a plus r2b plus r3c, where abc are the basic parameters or vectors. Here, the Miller indices are considered as r1, r2, r3. For example, we need to consider the fractions in R1, R2, R3 are eliminated by multiplying all components by the common denominator. What is that one? By common denominator. For example, we take 1, 3 by 4, 1 by 2. So they are, what is the common denominator? That is 4. So 4, 4 by 4, 4 by 2. Then the Euler indices will be 4, 3, 2. For example, I'm taking a two-dimensional pattern. In the two-dimensional pattern, on x-axis the intercept is 4a, and y-axis it is minus 2b. Then what are Miller indices in 2D? The Miller indices in 2D is what? That is 4 minus 2. Why minus 2? Because that is negative. That is negative y. See, the 4a is indicating x-axis in positive direction. The minus 2 is indicating y direction, but is in negative characteristic. It is in negative direction. That is the reason we took minus 2b. So, but in Miller indices, we are not using 4 minus 2. We are going to use 4 2 bar, where 2 bar is indicating negative sign. We already discussed previously. The direction or the negative symbol is denoted by bar. So here minus 2 is there, minus 2 is denoted by 2 bar. Here, how to write Miller indices? What is the procedure? First, identify the plane intercept on the x, y, z axis you take XY Z axis. Upon XY Z axis, we need to identify intercepts. For example, A, B, C. Specify the intercepts A, B, C and take the reciprocal form of intercepts. What is that? 1 by A, 1 by B, 1 by C. We need to take the intercepts into which form? Into a reciprocal form, that is 1 by A, 1 by B, 1 by C. Then we need to take into whole fraction form. Thereafter, we need to calculate into least form. The least form answer is your Miller indices. Like that, we are going to calculate the or write the Miller indices. For example, sorry, Miller indices. Next session is Miller indices for planes and their explanation. Now I am going to attach or taking the Miller indices for whom? For the planes. In place, how we are going to write the Miller indices. For example, consider a plane in a pink. For example, take this picture. So plane in pink, which is one of infinite number of parallel plane, each a consistent distance. So here the pink one is there are number of planes are there, but each of the plane is separated by a particular means constant distance, that is small a. Away from whom? Away from origin. Where is origin? The purple color one is nothing but origin. From the origin it is away. Which the pink color one, it is there are so many planes there in pink color. So the pink colors one are separated by a distance a. Then the plane intersects the x-axis at A. So whatever planes we have, the pink color planes are intersect the x-axis where? At point A. And this x-axis is parallel to y and z. The x-axis is parallel to y and z. Then how you can design the plane? The plane is represented as an x-axis one and x-axis and y. There is we are only consider x-axis, not y and z. That is the reason we took the one number for the x-axis and infinite for the y and z. So that is one infinite for the x-axis. This is the thing. We don't have anything on y and z. That is the reason we simply left as blank. Likewise, the yellow plane can be designed. So yellow means what? Yellow means here you need to take the y direction. We need to take, say this is the y direction. I forgot to mention the wrong color. I forgot to mention the color. So here the yellow one is represented as what? Here likewise we are going to represent the yellow one. So here is sorry, here I took that one. So that is and y-axis. So the y-axis is parallel to whom? It is parallel to the z and x. So z axis is infinite, x is infinite. So infinite, one infinite. Similarly, on the green, green is parallel to green is where you consider green. Green we can consider on z axis. So z is the parallel to whom? Z is parallel to x and y. So that's why x is infinite, y is infinite. Then it is the planes on green is what? The integers on green is infinite, one. That's it. So this is the thing. Now I am taking a particular problem. So in the problem I have a x, y, z. On x-axis we have some intercept, that is a 0 0 and y-axis 0 a 0. But we don't have anything on z-axis. We don't have anything on z-axis. That's why it is an infinite thing. Then calculate what are the Miller indices. Let's see. The plane of intersect cuts two of the crystallographic axis. So the crystallographic axis the planes of intersects cuts two of the crystallographic axis. So what is that one? On x is a 0 0 and y is 0 0 0 0 a 0 and z axis nothing is there. So on x axis the parameter is 1 and y axis the parameter is 1 and z we don't have anything. That's the reason we need to take the infinite Then the intercepts on this particular figure is on xy is 1 1 and z is 0, sorry, and z is infinite. Then the intercept is 1 by a 1 by a, sorry, 1 by 1. We need to consider into which form? The reciprocal form. 1 by 1 1 by 1 1 by, sorry, infinite by 1. Then it is 1 by 1 is 1, 1 by 1 is 1, infinite by 1 is 0. So the answer is 0. So like that we are calculating the Miller indices. Thank you.